Well, good morning, Cambridge. Marc Braun here, and I'm excited. I just got the ASHRAE journal for January of 2016, and if you look at the letters to editors on page 14, our letter got published, which was great. Let me read it to you. Just a little background. A direct fired technology article was put in the September's issue, and here it says, September's direct fired technology article draws the flawed conclusion that the advantages of 100% outside air direct-fired technologies, they said, quote, do not translate well into space heating applications. This article omits the benefits and application of high-temperature heating and ventilation technologies, which are 100% outside air technologies for space heating specifically. It goes on to say HTHV technologies are energy efficient and provide destratification. A recent study, which you guys are very familiar with, the DOE study, basically it demonstrated a 20% gas savings and a 15% source energy savings over traditional space heating technologies. And so for them to say that it doesn't translate well into space heating technologies, and then the Department of Energy to say it actually gives a 20% savings over the traditional space heating technologies of unit heaters makes them know that they were off base. The article also, in the Department of Energy, also reviewed stratification and concluded that these technologies destratify the space due to their high-velocity blowers. The same study concludes that during intermittent operation, these units merely offset infiltration rather than adding to the air load, and during continuous operation, these units provide both heating and ventilation in a compact single unit. The DOE study disproves the article's main conclusion, so that was really hard for them to hear. HTHV technologies provide heating and ventilation in a single unit. One of the things that they claimed in the article was that 100% outside air technologies used for space heating can't ventilate and can't meet ASHRAE 62.1. Direct-fired 100% outside air systems provide controls to operate either continuously or intermittently based on the design requirements. These controls can be programmed based on occupancy schedule, process conditions, pressure, or any other number of other control requirements. The article insinuates that these technologies must be run intermittently to offset the heat load, which is simply not accurate. And the third is that HTHV technologies provide energy efficient pressure control. So the article's main conclusions, besides saying that 100% outside air technologies can't be used for space heating, or shouldn't be used for space heating, are that recirculation and variable 80-20 systems were the best method for pressure control. What this letter states is that 100% outside air technologies are completely capable of being controlled as a positive, negative, or neutral pressure at the discretion of the design engineer. The article fails to mention that if variable ventilation is the requirement, a variable frequency drive on the 100% outside air technology is a more energy efficient method than a variable recirculating system to maintain pressure, as it can operate at partial load to save electrical consumption. What was really cool is the author's responses. They basically agreed that the Department of Energy study does prove that 100% outside air technologies translate well into space heating, which was against their main article. They said that HTHV units, when operated intermittently, do not meet 62.1, but when operated continuously do, which we agree with. And then they agree that variable ventilation and exhaust applications would be most efficiently done with VFDs on 100% outside air technologies. So really it was great to see their response and agreement of the main points of the letter. They do, their conclusion, they still say that recirculation offers some advantages because it's recirculating some of the technologies. We've got side-by-side comparisons showing massive savings when you convert from recirculation to 100% outside air HTHV technologies, and I would love to see their studies doing the same. We can share and compare. They've got smart engineers. It's fun to see real data, and I'm so glad that they were able to withdraw their statements, their inaccurate statements from the article's main points. So thanks, Marc Braun, Cambridge Engineering, signing out.